Hello students, the topic that we are going to see today is a gearbox. I'm sure you must have used a gear while riding a two-wheeler or four-wheeler. In this video, we are going to learn about the uses of gear and the types of gear.
In general, there will be a lot of resistance for a vehicle to move in the room. This resistance is because of the road, the air and load of the vehicle. A gearbox helps us to attain different torque and speed to overcome these resistance. When a set of gear is arranged in a shaft, it is called gear train. There are three different types of gear trains: simple gear train, compound gear train, and power train. Simple gear train. When there is only one gear on each shaft, then it is known as simple gear train. A simple gear train is designed for one of the purposes: to increase torque, to increase speed, and to increase direction. Like I said here, the small gear rotates and drives the bigger gear to rotate. For example, let's say gear 1 has 10 teeth and gear 2 has 20 teeth. Assume gear 1 rotates at 50 rpm. So, to find the gear ratio or speed ratio is equal to number of teeth on the driven divided by number of teeth on the driver. Gear ratio is equal to T2 divided by T1. In this case, T2 is 10 and T1 is 20. So, 10 divided by 20, which is equal to 1 by 2 or 1:2. So, T1 into N1 is equal to T2 into N2. So effectively, N2 is equal to T1 into N1 divided by T2 in this case, which is equal to 10 into 50 divided by 20, which is equal to 25. So N2 is equal to 25. The next one is compound gear train. When there are more than one gear on a shaft, it is called a compound gear train. In this type, there is an intermediate gear which helps the driver gear to rotate the driven gear. These types of gear trains are mostly used in automobile gear system, lathe machines, clocks and watches. Generally, compound gear trains are used where the generated power must be regulated before the usage. The formula to find the gear ratio here is gear ratio is equal to product of the number of teeth on the driven divided by product of the number of teeth on the driver. The last type is power train. In this type of gear train, there are three shafts: the driver shaft, the counter shaft, and the main shaft. Here the driver shaft rotates along with gear 2, which helps to rotate gear 3, which is attached to the counter shaft. This helps to rotate all the gears in counter shaft, which leads to rotate the gears in main shaft that delivers the output. The following table shows the estimated speed of the vehicle for each gear transmission. Sliding mesh gearbox. Sliding mesh gearbox is nothing but a transmission system that consists of various sets of gears and shafts that are arranged together in an organized fashion. Here, the gear shifting is done by the sliding of gears towards the right and left over the shaft with the help of a gear lever operated by the driver. It has three shafts: clutch shaft, lay shaft, and main shaft. The clutch shaft transmits the power from engine. The lay shaft acts as an intermediate shaft which helps in rotating the gears of main shaft. The main shaft acts as an output shaft which transfers the power from engine. The next one is constant mesh gearbox. As the name states, in this gearbox, all the gears in the main shaft are constantly meshed with the responding gears in counter shaft. But there will be no power transmission. To transmit power here, we use the dog clutch. The dog clutch collides with the gears of main shaft and transmits the power received from the main shaft. In this type of gearbox, the helical gears are engaged, and since more than one tooth is in contact at a time, the gear shifting is so smooth. And also, since we use sliding dog clutch, The wear of gear is tooless. Now let's look at troubles caused by these gearboxes. Gear noise. The gearbox causes noise when the gear shifting fork is arranged improperly. The misalignment between the gearbox and engine also causes the gear noise. The gearbox need to be lubricated periodically. If not, it generates noise. Also, the broken gear teeth causes these kinds of noises. A bearing is a device placed between two bearing surfaces to reduce friction and the wear. These bearings are used at the following conditions: low rotating speed, very large bearing surface, low use application. Bushes. Bushes are cylindrically sheared and held in a place by press fit. Since bushes are typically made of a soft metal, they act like a bearing. Thrust washers. It's fitted with roller bearings. Thrust bearings or thrust washers are used to limit the end play and also reduce the friction between two rotating parts. Roller bearings are used in combination with flat thrust washers to control end play of a shaft or the gap between a gear and its drum. Square cut seals. It is similar to an O-ring. However, a square cut seal can withstand more axial movement than an O-ring can. Square cut seals have a rectangular or square cross section. They are designed this way to prevent the seal from rolling in its groove when there are large amount of axial movements. Metal sealing rings. The metal sealing rings are used at the places in which some or smoke leakage is acceptable. Metal sealing rings are used in pressurized transmissions. Ring seals are made of cast iron nylon or Teflon. Teflon seals. Some transmission use Teflon seals instead of metal seals. Teflon provides for a softer sealing surface which results in less wear on the surface that it rides on and therefore a longer lasting seal. Teflon seals are similar in appearance to metal seals except for the hook end type. The ends of locking and Teflon seals are cut at an angle. Now that we have seen the gear train and gearbox, let's learn about gears. There are 7 different types of gears: spur gear, helical gear, rack and pinion, worm gear, spiral bevel gear, spur bevel gear, herringbone gear. First, let's see about spur gears. Teeth are straight and parallel to the gear axis. Only one tooth is in contact at a time. No axial thrust is produced while transmitting torque, hence it is often used for reverse gear. In transmission, it transmits torque for parallel and non-coplanar shaft. The major drawback of spur gear is clicking noise during teeth contact. Now let us see about helical gears. Teeth are at an angle to the gear axis. More than one tooth are in contact at the same time. Axial thrust is produced while transmitting torque. Gear will move front and back. Now let us learn about rack and pinion. Teeth are parallel to the axis of the gears. One tooth is in contact. No axial thrust is produced while transmitting torque. It converts rotatory motion into linear motion and vice versa. Now let us learn about worm gears. Teeth are at an angle with the axis and are curved, more than one tooth in contact. Axial thrust is produced while transmitting torque. It transmits torque at right angle for parallel and non-coplanar shaft. Now let us learn about spiral bevel gears. Teeth are curved, more than one tooth in contact, produces axial thrust, used to transmit torque at 90-degree axis. Now let us learn about herringbone gear. Teeth are straight at an angle and opposite, more than one tooth in contact. Although teeth are inclined, the shaft does not produce axial thrust. It neutralizes the axial thrust. used to transmit torque from parallel and coplanar axis.
I hope you have a clear understanding about this topic.